Hello students, welcome to online classes. So today we'll start class 12 mathematics, chapter 1, relations and functions. So in this video we'll only study this relation. Okay? Now what happened? Student usually think that this relation function chapter is very difficult, but I'll say that this chapter is very easy. Why? There is no formula you have to remember. Only you have to remember that what is the definition. If you understand the definitions, then you can solve any problems. Okay, there are some symbols are there also, so you have to know the symbols also. So let us start. Okay, so before going to start relations, first we have to know the Cartesian product. These are relevant things. Okay, so let us recall it. Cartesian product of two sets. Suppose a set is given 1 2 3 4, B is 5 6 7 8. Then A cross B is nothing but the set of all ordered pairs whose first element is taken from first set and second element is taken from second set. Okay, means this is one of the reason why these type of elements are called ordered pairs. মানে আমি বলতে যাচ্ছি যে এই ধরনের এলিমেন্টস গুলারে why we say that them as ordered pairs, because এটা এই ধরনের এলিমেন্টের ফার্স্ট এলিমেন্টটা কই থেকে আসে, ফার্স্ট set, and second element is coming from second set. Okay, now relation from A to B. So we have understood what do you mean by Cartesian product. So relation from A to B is nothing but a subset of this Cartesian product A cross B taken out in some manner. Taken out in some manner. Okay. For example, if I take, suppose we are denoting R, relation R1, or you can say R equal to set of all ordered pairs such that A and B are both even. Okay, now see, and this, what are the elements? Now see, what are the elements in this set? A and B both are even, and A belongs to A, B belongs to B. So now see, what are the elements will come in this set R? What are the elements? A, if I took, means A and B both are even. So what are the even numbers? 2 and 4 in this set, and in this set 6 and 8. So 2 and 6, then 2 8, then 4 6, and 4 8. Okay, so let us take another example. Suppose this is denoted by R1, this is denoted by R2. Suppose A comma B such that A and B are both odd. Okay, means what is the manner now? A আর B এর মধ্যে ম্যানারটা কি আমরা কিভাবে ডিফাইন করছি রিলেশনটা? We are defining that both numbers should be odd. Okay, so this is what are the elements will come? What are the odd numbers? 1 3 and here 5 and 7. So 1 5, then 1 7, then 3 5 and 3 7. Okay, both this you check. This is a subset of A cross B, and this is also a subset of A cross B. Okay, now the elements A and B we are taking from the set. The manner we are taking, this is up to us. মানে এটা আমাদের উপরে ডিপেন্ড করব যে A and B এর ম্যানারটা কিভাবে ডিফাইন করব. Okay, you know what do you mean by domain, what do you mean by codomain, and what do you mean by range of a relation. Okay, domain means what? In a relation, the set of first element of the ordered pairs. So what will be the domain of first relation? 2 and 4. Okay, and what is this is for the domain for R1 relation, and this is for relation R2. What is the domain? You see, what is the first element in the ordered pairs? 1 and 3. So domain will be 1 and 3. Okay, now next codomain. Codomain is the set B. B set is the codomain. Okay, means if the relation is defined from A to B, then B set, second set is called your codomain. Okay, now sometimes we define from relation from A to A, set itself. Okay, so in that position codomain will be A. We'll see. Then range in a relation Range of a relation means what? In a relation, what are the ordered pairs? The second elements of the ordered pairs. The set of second elements of ordered pairs is called your range of the relation. What are the second elements? In first relation, this is your 6, 8. This is for your first relation R1. And second relation, what is the second element? You see 5, 7. Okay. What we have seen? What do you mean by a relation? Relation is nothing but if the two sets are defined from A to B. Okay, if the relation is defined from the set A to B, then it is nothing but your subset of the Cartesian product A cross B. Okay, now we are considering A is equal to 1, 2, 3, 4, set A. We can define the Cartesian product A cross A, obviously. Okay, so if we can define A cross A, then we can define easily the relations on this set also. So I have defined one relation R1 equal to 1, 1, 1, 2. So the manner is defined, means some elements is taken, two elements is taken. R3 is also same thing. Okay. Now see R3, A, B such that B equal to A plus A. A belongs to A and B belongs to B. So what are the ordered pairs will come? মানে এখানের মধ্যে কি কি ordered pair আসবে, ঠিক আছে? Now if I choose, suppose if I choose A equal to 1, then second element will be A belongs to A. If I choose element A equal to 1, so means this should be A belongs to A and B belongs to A also, because we are defining the relation on the set A. Now see B equal to A plus 8. If I choose A equal to 1, then what is the result? 8 plus 1 is 9. Is 9 belongs to A? No, it does not belongs to A. Okay, 1 and 8 does not belongs to the relation. Okay, so is there any element in this relation R3? No. So this set contains no elements. No elements. Which type of set will denote? Which type of set will use to denote? So this is your empty relation. Okay. So next you see R4, A, B such that A minus modulus of A minus B greater or equal to 0. A belongs to A, B belongs to A. Okay. So what are the elements in this element? What are the elements in this relation will come? What are the ordered pairs it will come? 1, 1. Yes, it will come. 1, 2. Yes, it will come. Why? A minus B. A minus B greater or equal to 0. We know for any element in this set belongs to in this set, their difference is always greater or equal to 0. Their absolute difference, modulus is there. Absolute difference is always greater than or equal to 0. So all the elements up to 4, 4, all elements will come. That means what you can say A cross A. Means this R4 relation contains all the elements of A cross A. So this type of relation is called your universal relation. Universal relation. Okay. So first type, this type, some relation contain no elements. So no element contains this type of relation is called empty relation or null relation or void relation. And if a relation is equal to the Cartesian product on which it is defined, then it is called a universal relation. Okay, understood? So in types of relation, these two types of relation is also there: empty relation or void relation or null relation or universal relation. Okay, so mainly we will discuss the class 12 three types of relation. One is reflexive, another is symmetric, another is transitive. Okay, so let us see. First type of relation is reflexive. A relation R is said to be reflexive if A, A belongs to R for all A belongs to A. Meaning is what? Meaning is this. Which set, on which set we are defining the relation? যে সেটের মধ্যে আমরা রিলেশন ডিফাইন করতেছি তার প্রত্যেকটি এলিমেন্টের লাগিয়া কি হতে লাগবে? A, A belongs to R হতে লাগবে. For example, if we are considering the set A, then this type of relation, for example R1 equal to, if I consider 1, 1, 2, 2, then 3, 3 and 4, 4. This is a reflexive relation. For every A belongs to A, মানে এর প্রত্যেকটি এর মধ্যে যে এলিমেন্টগুলো থাকবে, এ সেটের মধ্যে যে এলিমেন্টগুলো থাকবে তার প্রত্যেকটি সেটের সঙ্গে কি আসতে লাগবে? ডাবলেট আসতে লাগবে. Okay, so this type of relation is called your reflexive relation. For example, another example, let us take R2 equal to 1, 2, 1, 1, 2, 3, 2, 2, 3, 3 and 4, 4. Can I say this is a reflexive relation? Yes. Check. For reflexive relation, what we need to find for every a belongs to the set a comma a belongs to r মানে এর মধ্যে যতটা এলিমেন্ট থাকবে তার প্রত্যেকটি ডাবলেট কি থাকতে লাগবে তো আমরা only will check the doublet what are the elements 1 so 1 1 is there 2 next element is 2 2 2 is there next element is 3 3 3 is there next element is 4 4 4 4 is there so we'll say this is a reflexive type of relation understood other elements are there 2 3 and 1 2 is there okay so আমরা এইগুলো দেখব ঠিক আছে 1 2 2 3 এটাই আমরা যে রিফ্লেক্সিভ রিলেশন হবে কি না এটার মধ্যে কোনো ডিফারেন্স আসে যায় না why because reflexive definition says that এর প্রত্যেকটি এলিমেন্টের ডাবলেট থাকতে লাগবে only this is the definition of your reflexive relation okay understood now see 1 1 2 2 3 3 4 4 belongs to the relation R we can say means 1 1 belongs to the relation R1 we can say okay so this can be written as also symbolized a1 is related to 1 this read as 1 is related to 1 okay in this way also a comma a belongs to R this 1 1 belongs to R meaning is this can be symbolized by like this way okay now for the relation R1 2 3 is it belongs to R1 no 2 3 is not there in R1 so this is symbolized as 2 R1 3 does not related to okay in this we have written 1 is related to now we'll say 2 does not related to 3 okay so general symbol is this if AB belongs to any relation R then we'll say A is related to B you read as A is related to B like that okay or somewhere if it is written there the meaning is this and if it is said that A comma B does not belongs to the relation then it is read as A does not belongs to A does not related to B okay so let us see next type of relation number 2 symmetric so a relation R is said to be symmetric if for A comma B belongs to R imply that B comma A belongs to R means যে সমস্ত এলিমেন্ট A comma B মানে অর্ডার পেয়ার যেগুলো থাকবে তার উল্টাটাও থাকতে লাগবে যদি if this happens then this type of relation is called your symmetric relation now let us check with an example 1 2 is there so what is the reverse of this 1 2 2 1 আমরা symmetric relation এর মধ্যে কি দেখতে লাগবে যে রিলেশনের মধ্যে যেগুলো অর্ডার পেয়ার থাকবে তার উল্টাটা থাকতে লাগবে okay so 1 2 is there is 2 1 is there no so straightforward will reject this is not a symmetric relation next relation let us check 1 1 what is the reverse of this 1 1 again yes it is there 1 2 what is the reverse 2 1 is it is there 2 2 what is the reverse 2 2 so is it a symmetric relation you give answer in your copy yes obviously this is a symmetric relation next R3 let us check 1 2 is there what is the reverse 1 2 2 1 so it is also a symmetric relation okay so let us see next type of relation so number 3 type of relation is transitive relation a relation R is said to be transitive if A comma B comma C belongs to R then if it implies that S comma C belongs to R then it is said to be transitive meaning is that মানে যদি একটা রিলেশনের মধ্যে 1 2 মানে AB আর BC মানে কি যে ফার্স্ট অর্ডার পেয়ারের সেকেন্ড এলিমেন্ট এন্ড সেকেন্ড অর্ডার পেয়ারের ফার্স্ট এলিমেন্ট if this type of element are there in the relation then if these two types of means A comma B this is our A comma B and this is our B comma C if these two order pairs are there which type of order pair first order pair এর second element and second order pair এর first element যদি ইকুয়াল থাকে ঠিক আছে তাহলে আমরা কি দেখতে হবে যে A comma C that means if in that relation what is A comma C 1 1 is must be there so this type of relation is said to be your transitive okay if this type of elements are not there A comma B if some A comma B is there meaning is there and trying to say is there 1 2 is there belongs to relation okay now next element must be 2 3 2 something there should be B comma C okay if B comma C is not there so that is by default this is a which type of relation transitive so let us try to understand this with an examples. So first example is R1. Okay, so let us check. 1 comma 1 is there, then this is our AB and BC 1 comma 2. Okay, so meaning is 1 comma C, that means A comma C, that means 1 comma 2. Yes, 1 comma 2 is there. Then AB, then this is our BC. Okay, then 1 comma 3, yes, it is there. Then AB 2 comma 3, then 2 comma 1, 2 comma 3, then 2 comma 1, then AC 2 comma 1. Okay, and next 1 comma 3, this is our AB. Here 1 comma 3 is there, but 3 comma something is not there. This element does not belong to the relation. So by default means আমরা 1 comma 3 AB পেয়ে গেছি, কিন্তু AC BC টা পাই নাই for 1 3. So এই এলিমেন্টে আমাদের কোনো যায় আসে না. So this is a transitive relation. Okay, next check 1 comma 1 and 1 comma 4. So what is AC? 1 comma 4. So it is not there to straightforward, it is not a transitive relation. Then next check 1 comma 1. So then let's just check another one. 1 comma 1 is there, then 1 comma 2. So 1 comma 2, yes, it is there. Then 2 comma 2, is there an element? 2 comma 2, 2 comma something? No. So we don't have to check. We don't need to check. 3 comma 3, 3 comma something is not there. 4 comma 4, 4 comma something is not there. So by default means we have only find two pairs, A comma B and B comma C. Okay. So and implying that also AC is there. So this is a transitive relation. Main thing is that in a transitive relation, if A comma B and B comma C are there, so you have to check whether AC is there or not. Okay, if A comma B is there and there is no B and C, then we need not to check that whether A comma C is there or not. Okay, so let us try to solve some examples. R is a relation given A comma B, manner is A minus B is divisible by 2 on the set of integers. A and B are what? Set of integers, means Z. A comma B belongs to Z. Okay, right? A comma B belongs to Z. Check whether this relation is reflexive, symmetric or transitive. For reflexive property, we know that A comma A belongs to the relation. Okay, for every A belongs to the set. Now set is defined as Z, set of integers. Okay, now এই রিলেশনের মধ্যে A comma A belongs to R হতে হলে, মানে A comma A এই অর্ডার পেয়ারটা থাকতে হলে, তাহলে আমাদের কি ম্যানারটা স্যাটিসফাই করতে লাগবে যে A minus B means their difference must be divisible by 2. So we can say A minus A 0 is divisible by 2 for every A belongs to Z. Therefore we can say A comma A belongs to the relation for every A belongs to Z. Okay, so this is a reflexive relation. Next type, symmetric. What do you mean by symmetric? Means the ordered pair AB, which type of ordered pair AB is there in the relation, then their ulta must be there. Means এটার উল্টাটা থাকতে লাগবে, ঠিক আছে? So let us take, let A comma B belongs to the relation. If A comma B belongs to the relation, meaning is that what? A minus B is divisible by 2. This is the manner in the relation it is defined, divisible by 2. This implies you can say minus of B minus A is divisible by 2. Why you can say, we can take example 4 is divisible by 2, then if I take minus of 4, then also it is divisible by 2. So that B comma A ordered pair belongs to the R. So therefore we can say, from this we can say this is a which type of relation? This is a which type of relation? Symmetric relation. Now next is this transitive relation. For transitive relation we have to take A comma B comma C belongs to R. Okay, therefore if A comma B and B comma C belongs to R, then we can say A minus B and B minus C both divisible by 2. If two numbers are there which is both divisible by 2, then their sum is always divisible by 2. Suppose for example 4 and 6 both divisible by 2, then their sum 10 which is divisible by 2. So you can say A minus B plus of B minus C is also divisible by 2. So this implies you can say minus B plus B get cancelled. So A minus C is also divisible by 2. So if A minus C is divisible by 2, what it means? That means A comma C belongs to the relation. Okay. So what from this what we can say that this relation is also transitive. Okay. So for transitive relation, what we have to check? First we have to assume that a comma b comma b comma c belongs to R, and we have to show a comma c belongs to R. Then it is a transitive relation. Okay. So if a relation is given and that relation is both reflexive, symmetric and transitive, both three properties satisfied, then this type of relation is called an equivalence relation. Equivalence relation. So what is the definition of equivalence relation? A relation R is said to be equivalence if it is reflexive, symmetric and transitive. So if some question says that show that the following relation is an equivalence relation, then what you have to check whether this relation is reflexive, symmetric or transitive. Any one of the property if does not satisfy the relation, then it is not an equivalence relation. Okay. Let us check. Let us tell you another thing. If number of elements in a set A is P and number of elements in a set B is Q, then we always remember that number of relations we can define from the set A to B is always 2 to the power P into Q. For this set, how many relations you can define? 2 to the power 16 relations you can define. Okay. So in our next video, we try to solve some other problems and we'll see the next concepts also. Okay.